Hi, everybody. Welcome to the Data Science Hangout. If we haven't met yet, I'm Rachel. I lead customer marketing at Posit. Posit's an open source data science company building tools for the individual, team, and enterprise. And I'm so happy to have you all hanging out with us today. The Hangout is our open space to hear what's going on in the world of data across different industries, connect with others facing similar things as you. And we get together here every Thursday at the same time, same place. So if you're watching this as a recording in the future and want to join us live, there will be details to add it to your calendar below. And I love getting to see all the conversation and connections being made in the chat. So I just want to remind people, if you are interested in connecting with others, I want to encourage you to say hello in the chat and introduce yourself, your role, maybe some of the things that you work on or things you do for fun. We're all dedicated to keeping this the friendly and welcoming space that you all have made it. If you're hiring, please feel free to add any open roles in the chat as well. It's also 100% okay if you just want to listen in here, although we love getting to hear from you live. So there's 3 ways that you can ask questions or provide your own perspective. So you can raise your hand on Zoom and I'll call on you to jump in. You can put questions in the Zoom chat and put a little star or asterisk next to it if it's something you want me to read out loud instead. And then lastly, we have a Slido link where you can ask questions anonymously. And so with all that, I know you all have heard that spiel a bunch of times so far. Thank you for joining us. I'm so excited to be joined by my co-host today, Kshitij Srivastava is Director of Technology at Milliman. And Kshitij, I would love to have you introduce yourself first here and share a little bit about your role, but also something you do for fun too.
Yeah. Thanks, Rachel. Thanks for having me today. Yeah, good to chat. Great to meet everyone today. My background is in data science. I've spent around closing to a decade at Milliman, but started my career as a data scientist, and my focus was, started in the big tech firms, but moved to insurance companies or insurance consulting to be specific. Very close after I started in data science. And when I joined, I was working primarily with actuaries. So not sure how many folks here know the actuarial workflows, what actuaries do, etc. So I'll give a fair background about the actuarial profession first, because that's very important to my own career. But yeah, in Milliman, it's a traditionally actuarial consulting firm, but we're trying to expand to sort of serve other areas of the insurance business from actuarial now. My own role has sort of started from data science, moved to data engineering, now leading a team of data scientists, data engineers, DevOps, technology professionals on creating applications for actuaries. So I'm happy to talk about sort of data science applications and within the broader insurance space, but more kind of specifically on the actuarial space. So yeah, I'm happy to be here. I hope this is helpful for everyone. And
Thank you so much for joining us. And one quick thing, what's something you like to do outside of work too?
Oh yeah, my work has in the last couple of years, I'm sorry to say it's been very hectic. So I've been moving geographies quite a lot, and that has left very less time for me to sort of engage in my hobbies. But when I have free time, I like to be outdoors. I like to hike. I like to sort of go out. Very recently, I think I've actually met some Posit folks at the Data and AI Summit in San Francisco. So I remember while I was there, I had one day which was, I didn't have any meetings there. So I took an 11-mile hike, and it feels really good. But yeah, if I feel like outside of work, that's what I do. I have two young girls, so I spend a lot of time with them at home, sort of, hanging around, and though both are pre-K, so just spending time with them, sort of preparing them for kindergarten. So yeah.
Awesome. Well, thank you so much. That's pretty impressive. You're at the Databricks Summit and you just decided, I'll go take an 11-mile hike.
Yeah. I mean, it was great. It was my first time to that part of the world. So after our meetings, it's a beautiful area. So yeah, it was neat.
That's awesome. I wanted to say thank you to you real quick here because I remember you spoke at the very first customer meetup that I ever hosted on getting insurance customers together. And that was actually when I was still in a sales role and I was making the case for this community role to be full-time. And so thank you. I realized that was all the way back in 2020 when we did that.
Yeah, I recall that. This was with Guy Olin, who was my prior colleague at Milliman, and myself, sort of, talking to a few insurance customers. And it seems like the community has come a long way till then. So
Yeah, well, thank you. So to kick us off here, I know you gave us a little background on the work that you do and working with actuaries, but could you give us a few examples on maybe use cases of data science across the organization, just to kind of put us all in your mindset and your day-to-day?
yeah. So I think it probably. I mean, I don't know how many of our attendees are from the insurance space or have kind of exposure to the insurance space, but I'll briefly go over the insurance space in general, sort of what are the various functions at an insurance company, how how data management, data sciences can help in decision making at each of these functions, and then I'll jump briefly to sort of what has been the recent trends that we've been seeing in this space, and cover the areas where innovation is happening and sort of where we see opportunities. So, kind of going back to the basics, uh, an insurance company, in general, insurance is pooling of risks. So uh, there needs to be measurement of risks to be able to insure it. So I think that's typically the actuarial function within the insurance company is responsible for collecting data and then sort of defining and measuring risks. And this, I'm oversimplifying it, but this happens through sort of collecting a lot of data, collecting external data, and then actuaries sort of define actuarial assumptions, which are basically what are the risks that we're seeing with this particular product. So let's say if it's a life insurance product, for a life insurance product, there are various types of risks. It could be mortality risk, which is one of the primary risks with a life insurance product, but also lapse risk and premium persistency risks, the risks that people who have signed up to pay premiums will not pay premiums. People who are people will lapse out of policy. So these are various types of risks that each insurance product has, and I'm talking about risks from the perspective of the insurance company itself. And so like to study and measure each of these risks is a very data intensive process, as you can imagine. Specifically, if and in a lot of situations, companies are lucky if they have prior data that they can rely their assumptions on. But in a lot of situations where companies interested in launching a new type of product, so we're kind of offering new types of guarantees that has not, that the industry has not seen before, or there are no prior examples for. Then in those situations, it's tough to have data to back your assumptions. So typically there are sort of a lot of data science use cases in that area. Part of the work that Milliman does with a lot of our clients is to help them design these behavioral assumptions. And so we use a lot of machine learning models. We use sort of traditional statistical regression models to study. I would say our usage is more on the traditional statistical side rather than sort of more machine learning oriented, because in general, actuaries typically want to understand sort of the drivers of risk and sort of put a formula to it rather than, rather than sort of walking through a black box. So I'd say we we typically sort of help companies decide these assumptions through the use of data science. That's primarily what I got started doing at Milliman. This is 10 years ago. Now, so that's the actuarial use case. Now there's multiple other things that happen. So once you have these assumptions of how mortality risks would look like, there's typically actuarial modeling systems that actuaries use to sort of project these risks further down the future. So 30 years down the future, what are the reserves that I need? What is the presence value of the premiums that I'll get? Things like that. So actuarial modeling is another very deep area in actuarial studies, and typically my company helps with those types of models as well. Now these are not machine learning models; these are cash flow projections models. So we're taking sort of some assumptions and the present state of the policies, and then projecting them through various economic scenarios, 10 years, 20 years down the future. So traditionally, I think that's also a very data intensive process, but I'd say there's less data science there in the traditional sense of what data science implies. It's more simulations, it's more projecting things. And so I think insurance companies who have their own inbuilt actuarial modeling systems are very, very big users of compute, of cloud compute. And so in each of these projections, there's very large amounts of compute that's needed. So if you're aware about systems such as Integrate or Atlas or GGY Access, these are traditional systems that are used for cash flow projections. But more modern systems, so we started sort of doing some of this work on I think 6 years ago on our studio, the Posit Connect platform, and I know that a number of our clients are thinking about using more modern database systems such as Databricks and Snowflake for doing actuarial projections. So yeah, that's an interesting area. You can see sort of the innovation happening there. Now, if you move away a bit from actuarial, there's underwriting. So I think the way risks are measured and sort of is through underwriting. There are underwriters within the insurance company, and underwriting is a great example of how data science is operationalized, used within an insurance company. In general, I work within the life and annuity space. So in the life and annuity space, underwriting is, as you can imagine, very data intensive. And typically in this space, there's lots of usage of third-party data sets and like unstructured data sets. So companies might be relying on sort of RX data or prescriptions or medical history, financial history, those types of things that are typically obtained through third-party companies, and then sort of using very advanced machine learning models to determine risks. I'd say the use of less traditional statistical models, but more sort of machine learning approaches is prevalent in the underwriting space. Typically, if you move away from the life and annuity space to the property and casualty space, that's where you see a lot of innovation happening in the underwriting space with the use of images and videos and sort of geospatial data and whatnot. So I think that's a very interesting area of underwriting where data science is very prevalent.
I know
Yeah.
I know when we talked years ago, you were sharing a little bit about some of the production Shiny applications. Does some of this tie into those projects, like when you're showing risk projections?
Yeah. So Shiny is something that has been quite transformative for our team at Milliman here. In fact, some of the applications that we've developed on Shiny is actually in production, used by some of our clients to study their risks. This is, I would say, in both areas. Typically, what we have done is we have put the results of the models that we develop on policyholder behavior. So things like, how would people lapse out of their insurance policies? What is the timing of when people will start withdrawing from their annuity contracts? So typically, these are the models that we develop on a large amount of data that we collect from insurance companies. And then we allow these companies to visualize the model. So let's say you can visualize how are withdrawal rates or lapse rates within your own company versus in the industry. And that kind of gives you a sense of the type of risks that you're insuring, and maybe some actuarial decisions to be made later. But yeah, so for those types of use cases where we're putting the results of a business process like an actuarial modeling or policyholder behavior models, and then letting actuaries sort of play with that data through a dashboarding setup, I think Shiny has been quite helpful. We have tried other types of dashboarding platforms, but the flexibility that Shiny allows us is amazing. So one of the things, for example, is when companies want to look at their mortality data, they want to sort of define their own custom buckets. So some companies want to define buckets from 10 to 20, or maybe 10 to 20 is a wrong assumption, maybe 40 to 50 years old. But then some companies want to study their assumptions in 5-year thresholds of 40 to 45. Now, Shiny allows us to sort of programmatically set up these things in a way that's quite natural. In Shiny, you can also sort of generate UI components programmatically. That I think we've found that functionality very amazing, and kind of compared to sort of some of the other alternatives such as Tableau and Power BI. I think there's more flexibility here. So yeah, to answer your question, Rachel, we've used Shiny a lot in displaying the results of our studies, but towards the other extent, in actuarial modeling also, when an actuarial model runs, these are thousands of economic scenarios of how what macroeconomic situations will be there, and then for each of these situations there's a projection 30 years down the line. We've used Shiny to sort of let actuaries visualize the results of these projections also. And I think that has been less of a use case, though. The primary use case of Shiny is kind of letting customers sort of visualize the results of our data science models, such as policyholder behavior models. So I think that has been a very good use case.
Yeah. Thank you for that. I see Arsenis, you have a question in the chat, which is getting a lot of upvotes here right now. I want to jump into this one first.
Sure.
There you go.
Kshitij, thank you so much for joining us this morning, and thank you, Rachel. Yeah, my question is actually kind of high level. It's a little bit broad, but being in your industry, it's a pretty good intersection. And given what you do, it's about the intersection of statistics and data science. So my question was, have you noticed that newer data scientists, as you might know, for the last like 20 years, anybody who's a data scientist now probably came from another field. So are you finding that that data scientists now that are minted data scientists, have those degrees, that they have sufficiently strong backgrounds in statistics to keep up with actuaries, or are you finding that the two fields are kind of becoming distinct enough that it makes the search process for candidates a little bit different?
Yeah, that's a great question. So our team has both, actually. So we have traditionally actuaries. So actuaries are folks who've studied statistics and It is their training, professional training to sort of fit new types of distributions into statistical models. And our team also has data scientists who are sort of from the other side of the lens. Some of them have studied hard sciences and kind of transitioned to the data science field, or some actually have in the last 10 years, there's been a lot of university programs that have structured training around data science that has some of the folks that we have seen come from those programs are quite ahead in terms of their skill sets, the value that they bring to the table. So I would say some of these university and programs and sort of, I'm sure POSIT has done a lot in terms of data science education. I think that has really helped in terms of the quality of candidates that we've been seeing. But going back to your question, in terms of the actuarial skill set, in terms of statistics, and then how newer data scientists compare to those, I'd say traditionally actuaries do spend time with a lot of parametric models, so things like traditional regression techniques. And I mean, one of the advancements that we have seen in this space and in the space of policyholder behavior models in the last year was when we started using penalized regressions. And you can imagine that is like penalized regression is as old as time. I don't know since when people are sort of using lasso regression and whatnot, but it is only recent when actuaries started using those types of techniques to study and quantify policyholder behavior risks. So the actuarial profession, because of all the regulations and the SOPs surrounding it, is very slow moving. There's lots of approaches to do a certain workflow, but actuaries are very limited by sort of their experience, and in terms of the regulations, they're limited by things that they want to try and do. I'd say the data scientists are more sort of excited and more they bring the machine learning side of things more to the table, which has been quite useful for some of our work. So for example, I talked about policyholder behavior models in the context of penalized regressions. I remember that a data scientist on our team has kind of taken that and put it into a tree-based model, and sort of also that led to quite some insights around sort of which additional variables are important to predict that outcome. So I'd say data scientists are more faster moving, are more sort of keeping up with the latest trends in the actuarial models and sort of this statistical models, and actuaries are doing the catch-up game now.
Thank you. I see Bill and Libby both asked two questions around the third-party data, so maybe I'll combine these a little bit. But Bill's question was like, what percentage of data is like, or do you purchase packaged data? Is open government data useful? And then to add on to that, Libby asked, is there a vetting process for purchasing third-party data? Because I imagine it's a huge investment. So how do you ensure it's going to be valid and useful for your needs?
Yeah. So something that we've an initiative that our team was working on in the past year was to so all the data that we have corresponding to how policyholders use their policies, that's a longitudinal data. So you have, like, for one person, you have their entire history. Now we wanted to use that data set, condensed down to one row for each policyholder, and then try to develop a propensity to buy model. So for example, one of the questions that we're going to answer is which type of customers are prone to buy a GLWBs or a policy with lifetime benefits guarantees. we want to understand those customers better. And in terms of answering these questions, I'd say actuarial and insurance, the data that is there within the insurance company is limited. So we have to rely on sort of third-party data to understand their behaviors better. I would say something that we have found useful is partnering up with some traditional data aggregators. Now, usually there are these data aggregator companies that sort of work with open source data or sort of data that is open out in the world, and they scrape it, or they have partnerships with sort of various data sellers. And something that we have found useful is that when we work with one data aggregator, then sort of we get to sort of play with various types of data sets they have. Some of these data sets might have restrictions in terms of how we can use it. So for example, with the recent, I mean, there's a lot of regulation in this space, and it's been growing as we speak. So we cannot really make a decision on who to send a marketing communication to based on, like, we cannot make an individual decision. I think that's restricted by a local CCPA, the California Consumer Privacy Act. So we do it on a group level. So I think there's restrictions in terms of how we use this third-party data. But yeah, going back to the question, the vetting process is through, so like, some of these companies offer match rates. So some of these companies have like fuzzy matching, and we can sort of send them some anonymized information, and they can send us fuzzy matching rates. As you can imagine, like, some of the names do not match a lot of times, the addresses don't match, so we don't know if we're getting the right data or not. So there's various types of fuzzy matching algorithms that some of these data aggregators have that we tend to use to sort of figure out what is the amount of matching that we can get in terms of sort of what's getting the useful data. So I think that's the vetting process. In terms of how we use it, yeah, I think there's various types. I've described the marketing use case. In underwriting, for sure, there's RX providers, there's like various companies. Milliman has a practice called IntelliScript, which is, I think, one of the largest underwriting data providers in the US. And we have connects with sort of various health data providers and everything, and a very elaborate pipeline to sort of obtain that data, clean that data, and sort of make a product out of it. So yeah, there's being a data aggregator is a hard business. We've worked with a lot of data aggregators in the past. It is not easy to sort of form those data relationships and get these data sets, but those who have those relationships have an edge in terms of sort of the value that they can provide to insurance companies.
Yeah, thank you. And I mean, you just mentioned IntelliScript as well. So thinking about all this data across the company, do you collaborate with the other departments to share data across?
Yeah, I think Milliman traditionally is a very peculiar in the way that it is. IntelliScript is a Milliman practice. My own practice, which is called Life and Annuity Predictive Analytics, LAPA, is also a Milliman practice. But these are different Milliman practices, but these are all very, very decentralized. These are, you can think of them as kind of separate companies entirely, but kind of under the broader Milliman umbrella. So I think we have interacted with IntelliScript in the past on data science applications on sort of risk modeling, but IntelliScript's business is selling sort of the data that they have, and sort of allowing companies to underwrite using that data. So you can imagine that their biggest asset, biggest revenue generator is the quality of that data itself, and sort of the risk score that insurance companies can derive on a per policy basis based on this data. And in this situation, as you can imagine, and I imagine that's true for data aggregators also, they're very protective about their data. And so once the value is proven for that data, they don't want to let sort of other companies evaluate the quality of data. It's not so much out in the world to sort of evaluate as such, because they don't want to open themselves to the risk of sort of data evaluation and kind of comparison with other alternative data sets. Proving that value initially is hard enough. So once that is proven, I think they're quite protective of that data and sort of who they share with that data with. So I'd say, yeah, we've worked with some applications, but yeah, I think that's a totally separate business also.
Okay. Yeah, I'm just from like the community aspect, I'm always so curious to hear how big companies work together when there's like different pockets of data people all over the place. But I see Santiago asked some follow-up questions around Shiny, and I know you put an asterisk there, so I'll ask it. But Santiago, if you want to jump in at any point, feel free. But the question was, for the Shiny apps that you put into production, how do you handle load and multiple users? The question is it load balanced or auto scaling taken care of by a platform like AWS or Connect, or is it something else like different packages?
Yeah, good question. So I think when we started doing Shiny applications, we used Shiny Server open source. That was back in 2016, I'd say. And then we needed authentication because, as companies are giving us this data, they want to ensure that their data is safeguarded and that sort of, it is backed by best practices in terms of security and authentication, access control, etc. So we decided to move to using Shiny Server Professional Edition then. And for authentication, we used Auth0 to sort of work with Shiny. But in terms of right now, I think our tech stack is we use Posit Connect to host these applications, and then Auth0 again to sort of authorize access to these. But yeah, I think in terms of Shiny, that's what our tech stack is. I kind of forgot what was the point of this question. Can you describe?
Yeah, let me go up. There were a few in it, but it was also just talking about handling the load of multiple users.
Okay, yeah, sorry, I didn't touch on that. So in terms of load, I think something that we've found useful is like our SDET team, sort of after every release that, the release is coordinated through Azure DevOps. And so that's where code is pushed to GitHub, and then an automated deployment happens through Azure DevOps. Before we obtain a final approval on the production deployment, our testing team does a regression test, integration tests, and a load test, also. And load tests are, I do remember a package that was quite useful in load testing Shiny app. I think it was Shiny load tests. And so Shiny load test is something that we've used in the past, but I think at this point our testers are probably using things like Selenium to just run multiple hits on the site and kind of see the responsiveness of the graphs and charts. For example, through one of these load tests, we ended up optimizing our Snowflake queries that are used to generate these graphs. So I think load tests were quite useful there. But we're lucky also because our applications are not used 24/7. Right? The load is not that much. Actuaries tend to use it when it's an actual assumption setting cycle. So that's certain times in the year. But during those times in the year, yeah, we can have outputs of like 5 people at the same time using the site. So it helps using things like Shiny load test and then frameworks like Selenium to automate load tests. Yeah. So I mean, I just saw a follow-up question on our Selenium. I think something that our testers do is develop a Selenium framework independent of the Shiny and R packages, and this is primarily written in Python, and they can probably just hit the site and hit various UI components and kind of test changing the inputs and see the responsiveness of the graphs and charts. So you can do that through a UI framework like Selenium. You don't have to use Shiny load tests.
I see Edgar had a follow-up question. Edgar, do you want to jump in?
Hi, yeah. So for the SQL queries that you mentioned that you optimized, were you using SQL directly into the Shiny app, or was that initially like through dbplyr and then you realized that you needed something better?
dbplyr is amazing. That's when I think we started with using dbplyr, but then I feel like this might not reflect the current state of things on dbplyr. It might have received a lot of updates, but back like 5 years back or so, we started using direct queries to Snowflake rather than using dbplyr, because we saw some avenues of optimization in terms of timing of or even sort of how the queries run on Snowflake, sort of separating that into various parts and chunks rather than using dbplyr. So I think we needed that flexibility more at that point of time. But since then, I feel like I don't want to speak ill of dbplyr. I feel like it might have received a lot more updates and might be good for our use case now. But since then, we've stuck at using SQL queries directly on Snowflake.
Thank you. Yeah, usually dbplyr is going to improve, but it's going to be up to a certain point, right? Once you want something in production, you probably want to just optimize it yourself. But it does make sense that you use SQL directly. Thank you.
I know you touched on the process your team goes for deploying, where you have, maybe it's a staging environment or where people are doing testing. And I've realized that's a question a few customers have asked me about, because different companies use so many different processes for this. And people often ask, like, what's best practice? And I was just wondering, could you talk a little bit more about what that looks like at your organization?
Oh, sorry, best practices for what?
Well, you mentioned the way that when you deploy, you have this like testing environment, and some customers will ask for best practices there. I was just wondering what process you follow.
Yeah, so I think because of the heavy regulation and the data protection, sort of our security posture has to adhere to sort of our contracts with companies who give us data for studying policyholder behavior. And some of these companies are very large brick and mortar insurance companies, very old. They have very elaborate security contracts. So I think what we have done and what we've found useful is we've started getting a SOC 2 Type 2 audit almost 3 years back now. And as part of that audit, we need to have a formal release process. And our release process keeps on kind of evolving and changing according to the needs. But I can describe it as there's a development server. So it's traditionally like a POSIT Connect or a sort of our Studio terminal. It's not a server. It's on a shared desktop machine, Windows server. That's where development happens, and developers push those updates to the GitHub site. So there's traditionally 3 branches that develop, beta, and then actually for release candidate and prod. And traditionally, how things sort of flow in that manner. So once there's a push to the develop branch, there's Git rules that kind of creates pull requests to sort of have another developer review that code, sort of see like do like not look at it on the server itself, but maybe just look at the code that was added and kind of approve it. And once we have that, then it goes through then the develop server can keep kind of having a lot of updates, right, without being pushed to a release. So once we're ready to do a release, it goes to a beta stage. And on the beta server, there's developer reviews, but also there's a formal review from the testing team. So the testing team runs their automated test suite. If it's a new feature, so in Shiny, you can probably add maybe we added a separate section of the web app. So there's no automated tests for that. So we end up doing sort of manual tests there to sort of see if any other feature breaks or how the load is. And then, so that's around the beta. Once we're sort of fine with the beta stage, we push to release candidate. Release candidate is maybe just to sort of check business functionality, and load testing also happens on the release candidate stage, and that kind of leads to a production deployment. In each of these stages, for our SOC 2, we need to sort of capture approvals, produce them for audits, and so our auditors make sure that every code push or every release is kind of thoroughly vetted and tested. So that's typically how the release cycle is. Now, in some releases, in some situations, we may end up doing a hot fix. So that's a branch off of a production, and then we push directly to production, then bring that change back to develop. There can be rapid releases. So, there's situations where we need to put up something, quite soon, let's say for a conference or for a call or for a demo, then, that has a separate release cycle. But like in general, most updates go through sort of this release cycle.
Thank you. It's super helpful. And release cycle is the term that was not coming to mind when I was asking that. Brian, I see you asked a question around collaboration across the team. Do you want to jump in here? Can't hear you yet.
Yes,
There you are.
sorry. I was trying to get my thing going here. Yeah, so I think collaborating with a team in these contexts of data science, you see a lot of stuff with regard to agile processes and stuff from a software development perspective, but a lot of that seems to fall short when you're talking data science contexts, because there's a lot more experimentation and a lot more kind of gray areas as to what the next task is. And I was wondering if you have contended with that and how you've approached that in your teams.
Yeah. So in terms of model development, I feel like it was back when we started like developing these Shiny applications, there was we started following the agile methodology. I'd say we don't typically sort of stick to it all the time, but in as a general sort of North Star, I think that's what we try to do, is to sort of push updates faster, sort of, and have incremental updates and push things faster, but then sort of push hot fixes if needed. But that also sometimes it doesn't align with sort of the actuarial profession at all, because everything needs to be tested before we put things out. So so we need to sort of vet things before we sort of put it on. So sometimes the agile methodology sort of converts to a waterfall process for our software development. But I think your question is in terms of our modeling. In terms of models, I think something that we've followed is, I wouldn't say it's agile, but in that, so there's a process where we try to improve our behavior models, and in that process, there are various types of new variables that we want to try and see if that is a good predictor. And so that's it's a cyclical process in there, and that doesn't quite align to the agile way of developing and deploying. So I feel like we've tried to sort of educate ourselves about the modern machine learning operations, MLOps methodologies, and sort of stick to it. So in terms of we've used something like MLflow. I think there's an internal proof of concept going on MLflow, where part of our team is trying to use MLflow to track a lot of these experiments, track how adding these variables would affect, let's say, lapses or withdrawals, and then kind of have a nice dashboard to compare the results of all of these experimentation. And only after there's a decision on sort of what the actual parameters would look like, that we go to sort of the next stage, which is sort of the fitting testing stage. And at that point, we also bring in a holdout data set to sort of test the models. There is a testing data set that is deployed right on the website, so that's not part of the training. So we let our customers see the results of that model right on the testing data set when it is deployed. But in terms of development, yeah, so that's usually our process is kind of spend a lot of time in that experimentation stage, build some internal apps that help us to sort of visualize the results of that experimentation. It's hard to put a good word to sort of that process. I feel like we've been trying to educate ourselves about various advancements in the MLOps space to to sort of leverage all that. But it's a continuous process. There's so much innovation happening within the ML's ops spaces that is hard to keep track of.
I see Neil had asked a question a little earlier that was, you mentioned that in the actuarial space, there's a lot of innovation. What do you think are the conditions that allow for innovation, and how do you encourage this as a company?
Yeah. So I think I'd reframe that statement and say there's a lot of potential scope for innovation in the actuarial space. I would still say that it is a comparatively slower moving space because of age-old practices, and sort of I think there's also regulations. There's lots of standard operating procedures that actuaries need to follow. There's standards of practices that are there for virtually every activity in an actuarial space, like reserving, valuations, pricing. There's very strict guidelines on what actuaries should do and should not do. So that kind of restricts sort of a lot of trying out new methods. But I think what we've been trying to do in the space we're trying to get into is sort of use more modern methods and modern machine learning approaches to behavior modeling. We're opening up to sort of using some of the modern data platforms like Databricks and Snowflakes to sort of work on actuarial modeling. I feel like the driver of innovation in this space is primarily because, I mean, it is a data-oriented space. There's a lot of data that actuaries work with, and as you can imagine, advancement in the data management and data sciences space is very rapid at this time. So I think actuaries are, as I said, doing the catch-up game right now. We're trying to modernize our methods, use more modern data platforms. I think the innovation starts from the data platform itself before we move to data science. A lot of these processes are in Excel files, which sometimes can become quite large, very hard to keep track of, to version control, etc. So in the life and annuity space, the innovation starts from sort of moving away from those older Excel file-based methods to more modern methods, leveraging cloud and Jupyter notebooks and Python and R. In the modeling space, if you move away from data management to modeling, I feel like there's increasing innovation happening in terms of using advanced deep learning methods to study policyholder behavior, using third-party data. And as you sort of bring in more third-party data, there's various deep learning approaches. So if you're using image or sort of forms to inform your underwriting models, then a lot of innovation is happening there. Yeah, and the other driver of innovation that I've been seeing is generative AI. A lot, at least in the traditional brick and mortar companies, a lot of companies want to leverage generative AI, and they need to fix their data situation first to be able to use Gen AI methods. So a lot of scope, a lot of innovation is happening there in terms of modernizing their data management platform. So yeah, I think those are kind of the traditional drivers of innovation that we've been seeing in the actuarial space.
I'd been meaning to ask you this, and when you mentioned Excel, it just reminded me. Someone had recently reached out from another insurance company, and they're working with a group of Excel users who they want to maybe inspire to start to use data science for some of their workflows. And I guess I'll just say this broadly, they were interested in connecting with others in the insurance space who have done this. But I was just wondering, should you have any thoughts on that, or how it's worked at Milliman?
Excel is a great tool for quick, dirty ad hoc work, right? And it's quick to sort of prove concepts, and you can the flexibility that it brings is kind of unparalleled. You don't have to do any setup. It's all self-contained, and it can handle considerably large amount of data. It kind of gives you the tool to do these things. But when you're dealing with very large amounts of data, or when you need to have governed processes, I think that's when sort of we've found that there's a need to move away from Excel. So for example, a lot of companies use Excel for actuarial assumption setting, and these are very large Excel files with hundreds of graphs in them, and pivot tables, and it's hard to keep track of, and it takes 15 minutes sometimes to sort of open one of these files, and so there's a case to be made to move away from Excel, at least for situations where there's a large amount of data, and there needs to be a governed process to deploy the results of whatever is being done in that Excel. So I think that's been the driver of kind of the movement away from Excel. But I think you'd be surprised at a very large amount of companies sort of still using Excel in some of these very large processes like assumption setting, or I would be surprised even actuarial modeling. But as the data size increases, as they're kind of brought under scrutiny by regulators, etc., that's the push to move away from Excel to use some of the modern methods.
Thank you. I know we just have a few minutes here, and the hour always goes by so quickly. But I meant to ask earlier too, just to learn a little bit more on your career journey. So I know you went from data scientist to director of technology at Milliman. And before we go, I'm wondering if you could share any advice with us here for people who are looking to grow within their organizations.
Well, yeah, I think, I mean, it was probably 10 years ago when sort of there was, it is probably true right now, there's lots of opportunities to sort of make impact if you're good with data within an organization. Something that I've found useful for my own career mobility is to be flexible in terms of how to provide that business impact.